Hey, this is Math 6, Unit 7, Lesson 14. Distances on a coordinate plane. So we're going to explore distances on the coordinate plane today. So first of all, it says plot points in your assigned quadrant and label them with their coordinates. So what's going to happen first, your teacher's going to give you a quadrant, right? They might give you quadrant 1, right, which is over here. They might give you quadrant 2, which is this one over here. They might give you quadrant 3, or they might give you quadrant 4. And whatever the points they give you, they want you to plot those in the appropriate quadrants. So for example, they could give you -6, 3, and you could plot that there and put the point down where it belongs. They give you -4, 1, and you could plot a couple points, okay? You're going to put them down there, and then you're going to plot and label the 3 points in the quadrant, and then have a conversation with your people at your table or your group about what do you notice between the ones in your quadrant and the differences or similarities between the ones in other quadrants, okay? So I just picked a couple numbers here just as an example for me putting 3 points down. You're going to be given a quadrant and assigned some to plot, and then talk about with your partner there. All right, the next activity, activity number 2, signs of numbers in coordinates. So we're going to write the coordinates of each point. Okay, so A is located at, we can see here it's at 4 is the x value, and then the y is over here at 3. So if we go 4, and then we go 3, and so that's where A is located. B is located also at 4, right, in terms of the x value. It's also located at 4, but its y value puts it down here at -3. So there's a difference there, right? They're on the same vertical line because their distance from the y-axis is the same. It's all 4 away, but where they're located horizontally from the x-axis, one's positive and one's negative. C is located at 3, all right, here it is at 3, and down it's going down to -5. -5 right there. D, so we're going over -4 and down 1, 2, 3. So over -4 and -3 for D. And E, we're going 1, 2, 3, 4, 5, -5, and going up 1, 2, 3. And going up 3 like so. Okay, so again, we have our quadrants. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Now there's some questions here they want us to answer in terms of what we see happening with each of these, okay? Now again, this one's is in 1, B and C are both in 2, D is in 2, sorry, they're both in 4, sorry, and C is in 4 as well, D is in 3, and E is in 2. So on the next page it says answer these questions for each pair of points. How are the coordinates the same? How are they different? How far away from the y-axis to the left or the right of it? How far away from the x-axis above or below it? So you look at A and B, for example. How are A and B the same? Well, A and B, first of all, we see that they have what? The same x-coordinate, which means that they are the same distance away from the y-axis, which is why they are on the line for for this one here, for x equals 4. So that is where this is going to be taking place. Now what's different is they have opposites here, right? These are opposites. When you look at the +3 and the -3, that's the difference between point A and point B, right? It's going to be 1, 2, 3, 4 units away from the y-axis. It's also going to be 1, 2, 3 units away from the x-axis, but this one goes in a positive direction, this one goes in a negative direction, right? So here we're moving up that way, +3, this way we're going down, -3. And again here, we're going that way, +4, and this one we're going this way, +4. That's just comparing A and B, okay? When you look at the difference between B and D, which are the next ones here, here's B and here's D, we see that B and D, looking at the numbers, have similar numbers, right? 4, 3, 4, 3. The difference here is that, well, the similarity is that they both are at -3, meaning they're on this line right there. That they share in common, meaning they are both 1, 2, 3 units away in the negative direction from the x-axis. The difference is that one is to the left and one is to the right of the y-axis, making one negative and one positive in terms of the x value. Positive 4, negative 4. And that's what's taking place right there. Okay, so you can just be aware and look and notice these things. And then finally looking at A and D are here and here. They're across from each other. A is 4, 3, D is negative 4, negative 3. So while they have the same kind of numerical numbers, 4, 3, 4, 3, this one's positive, positive, this one's negative, negative, which puts them not just across this way, but diagonally opposite of each other. These are both number pairs are opposites. 4, negative 4 opposite, 3, negative 3 opposite, which means they're opposite of the coordinate plane like so. Okay, so kind of cool. All right. So any discussion on that, have that with your class, talk about other things you see, other things you notice there. Number 3 says, point F has the same coordinates as C, except its y-coordinate has the opposite sign. So C was at 3, negative 5, and so F has the same coordinates, except the y is opposite. So F is going to be what? Well, the 3 is still 3, and what's the opposite of negative 5? Positive 5. So we want to plot that point on the coordinate plane. So we're going to go up 3, 1, 2, 3, over 3, and up 1, 2, 3, 4, 5, and plot that there and call that point F. How far away are F and C from the x-axis? Well, the x-axis is here, so it's going to be 1, 2, 3, 4, 5, and this is 1, 2, 3, 4, 5. So we would say it's 5 units away from the x-axis. Oops, this one's here, 5 units. What's the distance between F and C? Now the distance is how far is it from F to C? And so it's 5 plus 5, which is going to be 10 units. Point G has the same coordinates as point E, except the x is the opposite. So what is E? E is negative 5, 3. So that makes G the opposite of the x. Opposite of negative 5 is positive 5, and the y stays the same. So let's plot that out. 5, 3, 5, 1, 2, 3. So there's G right there. Okay. How far away are G and E from the y-axis? Well, from the y, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. They're 5 units away from the y-axis. Oops, did it again. And what's the distance between them? Well, it would be 5 plus 5, which is a total of 10 units apart. Point H has the same coordinates as B, except both its coordinates have opposite signs. So what was B? Well, it looks like B is 4, negative 3. So H is going to be the opposite of both of them, so we'll do a negative 4 instead of positive, and we'll do a positive 3 instead of a negative. So plot that out there, negative 4, 1, 2, 3, and that's point H. There it is right there, and that's what we do for that one, and that's all there is to it. So we've plotted some extra ones. We plotted H, G, and F now on the grid. So there's H, G, and F. We plotted them, and we're seeing how they compare and relate to other ones. So just what we're doing, just get used to it. Get comfortable. Let's look at activity 3. Label each point with its coordinate. All right, so let's just say what they are. Here we're looking at, we're not on the line, we're in between negative 1 and 2, so we'd say we're about negative 1.5 for the x value. The y value is up here at 2, so put that right there. B is at between 3 and 4, so we're at 3.5, and the y value is at 2. C, we're also at 3.5 again, and the y value is here at negative 3. The D is at negative 3.5, and the y value is at negative 4.5. Oh, not negative 3.5, sorry. This is positive 3.5. But the y value is negative 4.5. The E, though, is at negative 1.5. And the y value is negative 4.5. Okay, So I have all those plotted. There they are. Next step, find the distance between each of the following pairs of points, B and C. So B is here and C is there, so we're looking at the distance between those right there. We see the scale is 1, so we're going to go 1, 2, 3, 4, 5 units between B and C. Between D and B, okay, we've already gone this way, we've gone 5. Now we'll go 6 and a little bit more, make 6.5 units. And between D and E, we have some whole numbers. We have 1, 2, 3, 4. Then we have 4.5, and another half makes 5. So 5 units there. Which of the points are 5 units from negative 1.5, comma negative 3? Well, let's plot it. Negative 1.5 and negative 3, 1, 2, 3, would be here. So which point is 5 units away from that? Okay, we can look up here and go 1, 2, 3, 4, 5. That seems to be the case. How about this one? We'd go halfway, 1, 2, 3, 4, 5. That looks like it is as well. So we would say A and C are both 5 units away from that point right there. Which of the points are 2 units away from negative 0.5 and 0.5 and negative 4.5? So 0.5 is here, and negative 4.5 is going to go down here, plot a point right there, and we want to be 2 units away. So 2 units is going to be 1, 2. That works there. And do I see another one? Nope, not quite. It'd have to be here, and it's not. So the only one that works is going to be E. And finally, plot a point that is 2.5 units from A and 9 units from E, and label it point P. So to be from A and E, we're going to be on the same line. So we can take it from A and go up 1, 2.5. We can call that M, and let's double check. Is that going to be 9 from E? Well, we have, looking at our half, we have a half there and a half there, so that's 1. And then 2, 3, 4, 5, 6, 7, 8, and 9. So there you are. There's our point M, and it's plotted and it's set to go. Okay. So the point and where are the coordinates at? Sorry, after that too. Negative 1.5, and it's going to be also up here at 4.5. If you did decimals throughout this, you could do negative 1.5 and 4.5. That would also be okay. Okay. All right. Looking at the summary real quick. The points here, A, B, C, and D, are shown in the plane. Notice they all have almost the same coordinates, except the signs are different. They're all the same distance from each axis, but are in different quadrants, right? So they're a different way because of different quadrants here. Again, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We can always tell which point a quadrant point is located by the signs of its coordinate. If it's positive and positive, it's in 1. If it's negative and positive, it's 2, and so on and so forth, okay? So kind of good to always remember positive is there, negative negative is there. That's the easy ones. And then this side over here is a positive x, this side's a negative x, this side's a positive y, this side's a negative y. And that's the way those are organized, always and forever. Okay? So keep that in mind, give yourself a little break here, work on your homework, and we'll come back and check it together in just a few minutes. Okay, homework time for Math 6, Unit 7, Lesson 14. Here are 4 points on a coordinate plane. Label each point with its coordinates. Okay, so first of all, let's label them. We'll start here. We have negative 3 and 3. So we have negative 3 is the x value, and 3 for the y value for k. Over here, we've gone over 3, and we've gone up 2. There's the x value for x. The y is over 2. And we've gone down 1, 2, 3 for negative 3. And over here we've gone over negative 5 and gone down 1, 2, 3, 4. So they're all labeled there. Now plot a point that is 3 units from point K and label it P. Okay? You could go up, down, left, right. You just want to go 3 units away. So I'll do 1, but you could do a different one if you chose to. Right? You could go 1, 2, 3. and plot that right there and call that point P. That's acceptable. You could also go over here and plot one. The thing is 3 units. And the next one, plot a point that is 2 units from M and call it W. So where's M? M is here, 2 units away. We can go up, 1, 2, put it right there, and call that W. You could also go this way, you can go this way, and you can go off the grid. So that's up to you how you want to do those ones. Number 2, each set of points are connected to form a line segment. What is the length of each? So they each make a line segment. Okay, so you can do the work on this, but remember that if they have the same x value, they're on the same line. So the distance between them would be the difference from the unmatching numbers, okay, from 5 to 6. So we would say that this is going to be 1 unit. Okay, again, if you wanted to, look back up here at your grid up here. Here's 3, 5 would be here, and 3, 6 would be here. So how far apart are those? 1, right? That's it. Over here, these match, so we're going to look at the difference between -6 and -3. The difference between -6 and -3 is going to be 3 units. That's how far apart -6 is from -3. And finally for E, the x value is the same, so we're going to look at the difference from 1 to -1. So it's like looking at a point here, -3, 1 is here, right? And -3, -1 is here, so how far apart are those two? It's 1, 2 units apart. On the coordinate plane, plot 4 points that are at least 3 units away from point -2, 1 and write the coordinates of each point. So we're going to do 4 points that are 3 away from -2, -1. So -2, -1 is here, so that's point P, what we're looking at, and we want to go 3 units away, 4 different points. Alright, so let's do that here. So 3 units away and 4 points from P. So we can go 1, 2, 3. We can go this way, 1, 2, 3. We can go down 1, 2, 3, and go over 1, 2, 3. So those are the 4 points that are all 3 units away. We're going to label them here. This one is at -2, 2. Here we're at 1, -1. So here we're over -2, and we're down to -4. And over here we're at -5, and we went down -1. So there they are. They're all plotted, and that's it. Okay, number 4. Okay, number 4 is a review. Okay, so let's keep this think how this is going to work here. Noah's recipe for sparkling orange juice uses 4 liters of orange juice and 5 liters of soda water, which means there's a total of 9 liters altogether for this sparkling orange juice. Noah prepares large batches of sparkling orange juice for school parties. He usually knows the total number of liters, the T, how many liters he's going to make to prepare. Write an equation that shows how Noah can find S, the number of liters of soda water, if he knows T. Okay, so here's what we know. In terms of the mixture, right, there's a total of 9 liters. So we know that the soda water is going to be 5 out of the 9 parts of the drink. That's for the soda water. And that's the soda. So soda is going to be 5 out of the 9 parts, whatever it might be. That's how much the soda is going to be. So in terms of the total, if you want to find out how much the soda you're going to use, you would take the 5/9 of the total, and that's going to give you how much soda you would use, because 5/9 of the total would tell you how much soda you're going to actually use. Just like you can also say that 4/9 of the total would tell you how much orange juice you would use. Okay, so the first question, that's what's looking for S. Now when we look at, I can put OJ there, okay? Sometimes the school purchases a certain number of juice. I guess they want us to use J, so let's use J instead of OJ, okay? Of liters of orange juice, and Noah needs to figure out how much sparkling orange juice he can make. Write an equation that he can use to find T if he knows J. So using this, let's move this down here. We know with this one, 4/9 of the, I did it on my notes too, 4/9 of the total, 4/9 of the total juice is going to tell you how much regular orange juice you're going to need. So if I want to find t, I need to get t by itself. So I multiply both sides by the reciprocal, and that eliminates. So the total is equal to 9/4 times j. Okay? It's a little interesting there. Just good to think about that the orange juice is 4/9 of the whole recipe, and the soda water is 5/9. And with that, you can help make yourself some equations. This one's probably a little trickier, and it's okay. Just kind of think it through a little bit, and it's review too. Okay, for a suitcase we checked on a flight, instead of carried by hand, it can weigh at most 50 pounds. His suitcase weighs 23 kilograms. Can he check the suitcase? Okay, well 10 kilograms is 22 pounds. We need to find out what 50 pounds is going to be in kilograms. So let's do this. Let's do kilograms, let's do pounds, and let's do a table. We know that 10 kilograms is the same as 22 pounds. All right? Okay, that's awesome news. Cool. So let's see. His is 23. We don't have 23 here. So that means if we double it, if we do 20 kilograms times 2, that becomes how many pounds? 44. All right, so now we're at 20. How do we get to 3? Well, we could do 1 kilogram, right? Because I can do this, 10, I can do divided by 10. And if I divide this by 10, 22 divided by 10 is 2.2. So now I have 1. Now let's go from 1, let's move that up to a 3. That's times 3. Times 3. Why 3? Because I want to get 20 and 3 together. So multiply by 3. This becomes 6.6. So now when I want 23, I can take this value from 20, this value from 6, and add them together. So 44 plus 6.6 equals, in this case here, 50.6. So a 23 kilogram bag would weigh 50.6 pounds. Will it be more than 50? Yes, it's more than 50. So can he check the bag or carry it in? He cannot, right? So it weighs too much, not going to work. Bummer for him. Okay, that's it for today. Have a great day, and we'll see you next time.